what is the -2 going to do to the graph? We're talking about those transformations again. And this looks a little bit different than what we did yesterday, because remember yesterday we were looking at something like f of x plus c, and we can't really see that here because we don't really have an f here. But this exponent is the same as this. Okay, so that's x -2 inside the parentheses. So that x -2 inside the parentheses is going to move our graph to the right too. And every expression is going to look a little bit different. The exponent here is going to tell us how far left or right we go. And then the -6 on the outside, the -6 here on the outside, that's going to tell us how far up or down we go. So in this case, we're going to go down 6. And that number has very big significance when it comes to almost everything we're going to talk about today. What is the asymptote? Well, the asymptote is -6. That is correct. The asymptote is whatever that vertical shift is. I would recommend putting that on my graph first. Now, can we sketch a decent graph without plotting any points? The answer is yes, we probably could. I know it's been moved to the right too, so my graph probably gonna look something like this, maybe, but that's not super accurate. But if we just wanted like, hey, what's the shape of the graph gonna kind of look like? And we're not really worried about the points being in specific places, that's pretty good, honestly. And that might be enough to get you the correct answer on a multiple choice test. But if we want to graph this a little bit more accurately, what might we need to do? At this point, we might need a table, perhaps. And we might need to figure out some points. So in Desmos, we can come back in here and we can type this in. We're going to have 2 raised to the parentheses. In Desmos, you have to use parentheses if you want to add or subtract in the exponent. Otherwise, it will not add it to the exponent. So we get 2 raised to the x1 -2 -6. And notice none of these points are really great because like they're all really, really close to the asymptote. But which way did we say our graph had moved? We said our graph had moved to the right too. So maybe I got this -5. Maybe I want some to a few more to the right of 2. So maybe like 4 or 5. And I'm not going to plot all of these. I'm just going to pick 2 of them. I'm going to pick one close to the asymptote. So maybe this 2 -5 is pretty close. And then one a little bit further away. So 5, 2. And that's the ones I would use to maybe graph this. So 2 -5. And then 5, +2. And then that should be a pretty good idea to see what this graph is going to look like. If I didn't include the 5 and the 2, I would get a decent picture. We have that, right? It's going to get closer to the asymptote on the left. We got to go up through that point. But without that second point, what's going to happen? Is my graph going to turn and go straight up? Is it going to go out? Is it going to go out? And like we just run into a lot of possibilities. The shape's still going to be the same, but we run into a lot of possibilities if we don't put that second point like 5, 2. It doesn't have to be 5, 2. That's the one I picked. Maybe you picked a different point, and that's okay. But now we have a pretty accurate, quickly sketched graph. I don't want you spending, 20 minutes trying to graph these and plot 20 different points. I don't want you doing that. Like, I know what the general shape should look like. I know it's been moved down 6. I know it's been moved to the right a little bit. We should be able to draw a pretty decent graph. All right, what about the domain? The domain for any exponential. There's no breaks in the graph. It goes left forever. It goes right forever. We will never, ever, ever get domain error if we plug numbers in for the variable in this case. Never. The range. That asymptote, we talked about that -6 earlier. It's going to show up like 3 different times. The range, we're going to go from -6 to infinity. We cannot actually touch -6. So that's why we're going to use a parentheses. That parentheses is what represents that. Like, hey, I get really, really close to that -6, but not quite there. So we're going to use parentheses. In behavior, if you want to use the left-right shorthand notation, you can if you want. But just remember, on a quiz or test, it will look something like this. It will look something like this. And with exponentials, one of these is always going to be equal to the asymptote. Which one? Well, it depends. It depends on like, has it been reflected? Is it growth or decay? all of those factors would weigh into which one of these would be the asymptote. But in this case, the left side of the graph is getting closer to the asymptote, which is -6. And the right side of the graph is going up to positive infinity. The right side of the graph is going up to positive infinity. What about the x and y intercepts? Well, if we looked at the graph, could we find the x and y intercepts exactly just by looking at the graph? Well, let's see. Well, here's the y-intercept right here. Where does that graph cross the y-axis exactly just by looking at the graph? It looks like about maybe like -5.5, but do we know if it's exactly -5.5? No. We don't. What about the x-intercept, which would be about right here? It looks like it's somewhere between 4 and 5 on my graph. Your graph might look a little bit different, but it looks like it's somewhere between 4 and 5. But can I tell exactly where that point is? No. So tomorrow, I'm going to show you how to do that algebraically. We're not doing it today, but tomorrow I'll show you how to find the x and y intercepts algebraically. And it's the same for any function, and it actually makes pretty good sense. But I'm not going to do it today. I'm going to do it tomorrow. There's several examples on here, so if you need to see.
If we moved it right, shouldn't the points be different, or?
If we had not moved it right, this point would be right here, and this point right here would actually be right there if we had not moved it to the right.
Okay, I think I'm wrong about my calculator.
But when we type it in and we put the numbers in the table, it's already moved it to the right for us.
Okay.
Does that make sense? Yeah, it's already moved it to the right for us. So the points on your calculator, it's already been moved. That is correct. I'm gonna skip number 4 unless you just really want to see it in a second. And I'm gonna do number 5. Number 5 is a exponential decay, but it does have a reflection. The negative in front we talked about yesterday. You need to know the transformations really well. The negative in front is going to be a reflection over the x-axis. You will definitely see a question on your test that's going to give you an equation just like number 5. And they're going to say, hey, which of the following are the correct transformations that have happened to this graph? And you need to be able to list them out. So the negative is going to be a reflection of the x-axis. The 1/2 is not going to do anything in this case. It's just the base. The +3, what's the +3 going to do? That exponent tells me how far left and right we moved, and it's kind of opposite of what we think. We think like +3 should go to the right, but no, not quite. We saw yesterday if I did x +3 inside the parentheses, it actually went to the left. So this problem here is going to go to the left 3. And what about the -1? The -1 has huge implications here. It's going to move my graph down 1. It's going to be the asymptote. It's going to talk about the end behavior is going to use that number. The range is going to use that number. That asymptote is really, really, really important. And where do we get that from? The vertical shift. We went down 1. That number is going to show up a whole bunch. That number is really important. And now, how can we plot some points here? I know what 1/2 should look like an exponential decay problem. It should start at the top left, and it should get closer to the asymptote as we go to the right. But that's been reflected. So this graph's going to start at the bottom left and get closer to the asymptote as I go to the right. So a very generic graph would look something like this. And if all I cared about was the shape, that would be good enough. But maybe we want this to be just a slight bit more accurate. Maybe I want to know some points on here. And we can figure those out by typing them in a table in the calculator. You can do it in your handheld calculator, or we can do it on Desmos. I'm going to change this to negative. I'm going to delete the 2 and make this a 1/2. We had plus something here, right? +3 maybe, and -1 there. And since we did go left 3, notice none of these points really give me a good picture of the graph. -2, -1.5, those are all really, really close to the asymptote. I need some points that are further away from the asymptote. So since we did go to the left 3, I'm going to go find some points like -4, -5, -6, and maybe I can use one of those a little bit better than the others. Does it matter which one of these we use? I'd probably use the one that's furthest away from the asymptote, which would be the -6, -9. And the -3, -2 would be okay, because it's pretty close to the asymptote. So -3, -2 as a point pretty close to the asymptote. And then -6, -9 is a point a little bit further away. Now, I'm only putting 2 points on here. Can you put 3, 4, 5, 6 points on your graph? As many as you want to put on your graph, put them on there, okay? The more points, the more accurate your graph's going to be. But I'm telling you that we really only need 2 to make this graph pretty accurate. Okay, we really only need 2 to make it really nice. Yes?
Just with my calculator doing matching up with the.
And at this point, we should be able to find the domain, the range, and all of that good stuff. I put the 1/2 in parentheses just to make sure the 1 would be, that 1 and the 2 would be there, the x plus 3. I don't know if that's gonna change anything. No, there's no that, Three.
Can you move -1/2?
Yeah. You don't have to.
But now, it's like, oh, wait.
That's what you do. That was good. Okay. I don't know what you had typed in.
It was probably the parentheses that did it.
Yes, let me finish right quick. The domain, would be -infinity to infinity. And that's true for any exponential function. All exponential functions, you can plug any x value you want. The graph's gonna go left and right forever. You're never going to skip a part of the graph. The range, this side of the graph, since it's been reflected, the range is gonna look a little bit different than the others we looked at. It's gonna go from -infinity up to the asymptote, in this case, is -1. And we're gonna use parentheses. And the end behavior, the statement that you need, for a quiz or test is gonna look like this. If you wanna write in the shorthand, that's okay. In this case, the left side of the graph is going down, and it's gonna go down to -infinity. The right side of the graph is underneath the asymptote, but it's still gonna be getting closer to that asymptote. And that's going to be, -1 in this case. That's gonna be -1 in this case. And that's all we're doing today.